All right, now on the back of our guided notes, we've got a few things here where we need to start to create some systems of equations. So in our very first example, we're going to go through and complete this table right here. We're given the equation y equals 2x minus 3. What is the slope and what is the y-intercept? So I can see that this equation is written in slope-intercept form. So we have y equals mx plus b. Now I know that plus b is going to be my y-intercept. So that means my y-intercept is -3. And then I can see that my slope is that m value. So that means my slope is 2. So in order to fill out our table, we have to create a few different systems of equations. So our system of equations, we need to create one first that has one solution. So I know that one solution is going to have a different slope for each equation. So my original equation had a slope of 2, which means I can pick any number but 2. So I could rewrite this equation, y equals 2x minus 3. Now I know that I have to have a different slope, so instead of 2, I can make that any number I want. Let's make it 5. Y equals 5x minus 3. Now I know that that's going to be a system of equations that has one solution because they have different slopes. So different slopes will cross. Lines with different slopes will cross only one time. So then it's going to have one solution. So now let's take a look at our next one. On our next one, we need to create one that has no solution. So if I were to look at the front of my guided notes, I would see that we said, all right, a system has no solution when it has the same slope and different y-intercepts. So if I have the same slope and different y-intercepts, that means I'm going to write my equation. All right, y equals 2x minus 3. I can have the same slope, so I'm going to keep my y equals 2, but I need to change my y-intercept. So instead of minus 3, I can make it literally anything else. Let's go minus 5. So now we've got a system that has no solution. And we know this in our explanation. We can say that this has no solution because parallel lines have the same slope and different y-intercepts and never intersect. Parallel lines have the same slope and different y-intercepts and never intersect. All right, so our next one, our last one that we've got to do here, we've already done our first one, which was one solution. We've done our second one, which is no solution. Now we need to create one that has infinite solutions. So when we're going to have infinite solutions, we know that we have to have an equation that's going to have the same slope and same y-intercept. So if we have the same slope and the same y-intercept, we're going to write our equation, y equals 2x minus 3. Well, our slope needs to be the same, so we're not going to change that. Our y-intercept needs to be the same, so we're not going to change that. So we're literally going to write the exact same equation. And we know this is going to be infinite solutions because coincident lines that's lines that are right on top of each other, coincident, have the same slope and y-intercepts. So now there's two more sets of systems of equations to create here with one solution, no solution, and infinite solutions. And then we'll finish up today with that independent IXL practice.